The broadcast is now starting. All attendees are in listen-only mode.
I can't see myself from here, am I?
So, yep, we have people here.
Okay, cool. Thanks very much. Hello, everyone. Welcome to the BCS webinar this evening on blockchain. And welcome to all our people online. This is the second time we're trialling the GoToWebinar technology rather than the GoToMeeting, which we had last time. So apologies to any of you who were trying to join last 2 months ago in February and were not able to get through. Hopefully it'll be easier to run through this evening. Just a couple of things about the webinar is people online are in listen-only mode. So you'll be able to type questions in the question box, which you can see as a dialogue box or on the panel on your right-hand side, assuming you still have the GoToWebinar window on the right-hand side. Anybody in the room here, we're going to have a microphone to ask questions, so there will be times to have questions throughout. I think Michael last time asked for questions at a number of different times, and just to check everyone was okay. And then we'll also have questions at the end, a bit of a discussion. It's about a 40-minute presentation, and so we'll go into question times at the end. I've just got a couple of things I wanted to make announcements of. Great. Is that only going to be there, not here? God damn it. That's all right. I can
There 1 moment, folks. There we go.
Yeah, cool. All right, thanks. Okay, so just the format for this evening, we're starting at about now. So then we'll have Michael presenting in about 5 minutes' time, and then for the people that are online, in the room here, we're going to have some refreshments before we close. I didn't introduce myself. My name is Marilyn Burt, and I'm the Vice Chair of the Specialist Group here for Configuration Management and Software Asset Management. And I've got a couple of events to let you know about. But for those of you that don't know about the British Computer Society, the predominant thing that really that got me involved in the Computer Society was really the ITIL methodology. And I think a lot of you will probably be more aware of that, and that's what you would probably associate with the BCS. So for configuration management and software asset management, we've combined in a specialist group, and we have monthly events where we alternate between software asset management specialists talking about licensing and specific models around software applications, especially enterprise type solutions. And then we have configuration management products and services mainly that we talk about for the other month, where we have specialists come in to talk about things around that area of expertise. Then the most exciting thing we've got happening at the moment is next month, apart from Michael's presentation this evening, obviously, which is why you're all here. But next month we have our annual conference, which is here in London. And during that conference, we'll have three streams running, and each of those streams, one is focused on software asset management, one is focused on configuration management, and the third one is focused on DevOps. So we'll have presenters throughout the day doing specialist topics on them. There's a web link there if you wanted to write that down for the people at home. I know it's not clickable. To have a look at the information as we're posting more about each of the speakers and what they're talking about. There's also an Eventbrite link that I've got on the bottom of the page here for where you can book your tickets and see more information. That Eventbrite link also tells you, or has the link that you can go to for the advertising of the actual next month's conference. Our keynote speaker is Mike Nagisa. I think I've said that right. I'm not sure. He's a CEO from Costner Group, so he'll be opening our conference next month. So please feel free to write those down. You can also get details from the link that we've got in the center of the page here, which is the bcscmsg.org.uk. And just obviously tonight's event is the first one on the top of the page. The next one I've got highlighted there in red is our annual conference. And then the following 2 months we have, in sequence beyond that, the configuration management presentation, and then following month will be the software asset management, and throughout the rest of the year. So just for this evening, we've got a presentation by Michael Stroh, who is one of our members in the specialist group. He's on the board with us, and he's been shifted to Australia with his ServiceNow job, so he still dials into our calls at this time in the morning, which is a bit early for him over there. He's an IT consultant with ServiceNow, and he has over 30 years experience in the computer industry within Australia, Europe and USA. The last 13 years were related to his service management and design and implementation of ITIL-based systems, especially configuration management and automated discovery applications. I've already mentioned he's a committee member. He's a member of the Association for Computing Machinery and has a Bachelor of Science and MBA and Master of IT from the University of Melbourne. Just a little bit, this is the information about what Michael's going to be talking about this evening, and I'm not going to hold you up on that because Michael will present it a lot better, but that's what you would have seen when you booked for this evening's event. So Michael, I'm just going to get Simon to switch over the presentations now, and you'll be ready to go.
Okay, Michael.
Okay. Good evening, everybody. Welcome to the presentation. My name is Michael Stroh, and I'm presenting from Melbourne, Australia. Today we'll be talking about the Blockchain CMDB, how to build in accuracy, reliability, and security into a CMDB implementation. So let's start. Let me see if I can. Here we go. Okay, basically the agenda tonight will be, first of all, we'll talk about what is a blockchain. Probably people have heard about the term blockchain being part of Bitcoin and other cryptocurrencies. And then we'll talk about blockchain and distributed ledgers. And then we'll talk about how can the blockchain help the CMDB. And for those who are unfamiliar with the CMDB, we'll just give an overview of this thing called the CMDB, the Configuration Management Database, that is really the underlying supportive structure of configuration management. And then we'll talk about a couple of use cases. One is in ITSM processes, incident problem change management. And another use case we'll talk about is the automated discovery of data center devices, and then we'll finish, and then there'll be some questions. But I must say that if anybody in the audience would like to ask a question, I'd be happy to answer that question and interrupt this presentation. That's kind of what would be a good thing, I think, for this presentation. Okay, so let's talk about what is a blockchain. Well, first of all, a blockchain is really just a type of data structure. The back end of this thing is a chain of blocks. It's literally database records joined together. It's like a database, but only adding is allowed. There's no deleting of records, and that helps to make the database secure. And so it's distributed instead of centralized. Now you can see on the diagram I've got here on the left is the classic model of a database where you have it centralized in the middle, and you have people and computer programs accessing the database, the central database. And in the distributed version, you have a copy of all of the nodes of all of the database in the nodes in this distributed fashion. Now we'll get into the details here, but there's really two parts to this blockchain. The first part is the actual connecting of the chain of blocks, and then there's the replication of that that blockchain in the network. Okay. Okay, so what happens is when you're adding a new block, each new block is added by using a cryptographic key. So what happens is the block's ID is generated. This ID here is generated by joining the key and the data into the block. Now, I've got a little demonstration. It's written in Java, and it's something that I wrote up, and it's like a very sort of rudimentary like tutorial, if you like, of what this actually means. So I've been able to actually craft this up in Java, and you can actually see it a bit later. I'll give a demo, but this is a diagram that shows the basic structure of a blockchain. It's simply just a chain of blocks that and then copies of the blockchain are sent to and authorized by the connected node. So it's not just a blockchain. All the blockchains that you see in the world at the moment, the most common one that everyone knows about being Bitcoin is that. So so let me just go back here. And so Bitcoin is an example of that, where you've got blocks connected together by chains, and basically you can see here there's the previous block has got that connection there to the first block, and that previous block is the connection to that block there, and so on and so forth. So each time you add a block to the blockchain, you have to actually cryptographically check to see what was the previous block, and then use that to create the cryptographic key of the current block. So that's the reason why it's very secure that way. Are there any questions so far? Can I ask in the audience, are there people that are quite familiar with blockchain who would say that they are, you know, they understand the workings of blockchain, and perhaps I should just move on with something a bit more technical?
Do you have? Yeah, just a question coming, Michael. Come to this microphone if you could.
Sorry, I'm new to this. Your arrows are going from right to left, from lower right to upper left as you go across to each block. But you start with block 3, or is that immaterial? Should be block 1 on the right, 2 and 3?
Well, it's a very good question. Okay, so what happens is the arrows are not the direction of connection; they're just a reference, basically. So you're starting with block 1, and you see here in the previous block is 0. So this is what they call in the parlance, the Genesis block, the very first block that's ever been created. So for instance, in Bitcoin, the very first block that was ever created by whoever it was, there was no previous block. So that's the very first block, and it's got no previous block. But what this is just not the arrow of direction of connection, but a reference, basically. So each block has to have a field called previous block, and that contains the hash, or the cryptographic hash of the data of that block. If that makes any sense. So you can see if you go look. I don't know how easy it is to see on your screen right there, but if you see the last 3 characters is 4, 5, 6 there, and that's the previous block 4, 5, 6. So that's the actual block there, and that's the previous block. So that's the second block, and the second block always has a copy of the previous block's hash in it, and that is also used to it's added together to generate the cryptographic key. Perhaps it might be useful to quickly go into I don't know whether you can see this screen here. This is a view of my a little tutorial computer program that shows that. So you can actually see here there's the structure, here, this is the structure, and here you have the structure as a block. This is a block, and it consists in the data part and a string called previous hash. Okay, this is the input to the block, and the block contains the hash, the current hash, the previous hash, that of the previous block. It contains the data, whatever data that is. In this case, my example is because it's a CMDB, it's data about a Linux server or a set of servers of Linux, right? And here's a timestamp, which does a date timestamp of the actual transaction, and this other thing, which is not so important at the moment. But here you can see when each block is built, you actually have to calculate the hash, and we do that after we've set we get the previous hash, we get the timestamp, we get the data, we mash it all up in this calculate hash function and produce the current hash for this particular block. So that's how it works. Does that kind of help to understand what's going on here?
Yep, you've got that, Michael.
Okay. Hold on a sec. Got to get this presenter view here. That's better. Okay, so does that help to answer the question a little bit? This idea, this arrow, and it's a very good question. The arrow is not really the direction. You don't start with block 3 and move to block 2 and block 1. You start with block 1, and that arrow is literally just a reference to block 2. It's not the direction of the connection, if that makes any sense. Okay. All right. So let's talk about, what is the relationship between databases, networks? It turns out that databases plus networks is equal to blockchain. It's a very simple kind of little arithmetic thing that I wrote up here, just to explain in a simple way how this blockchain is kind of like a combination of databases and networks. And it's all about I guess it's all about, you're talking about the E.F. Codd's relational data model. He created that in 1970, and then Tim Berners-Lee created another standard, the networking of computers, which is obviously the World Wide Web. And then in 2009, Satoshi Nakamoto, or whoever that was, created this idea of blockchain, which is like a combination of the database standards and the networking standards, but to actually make things happen using a blockchain. And it's kind of a new way to share the data. It's instead of this model here, you see, you've got this distributed model. You've got the databases, you've got the World Wide Web, and now you've got your blockchain, which is kind of a combination of those two previous technologies that works in a better way. So let's talk about databases, for instance. Well, before E.F. Codd, there were really no real database standards. I mean, each program had its own data structures, and it was really just a reinvent the wheel kind of thing. The algorithms were written specifically, one-off, tailored to bespoke data structures. It's a bit like writing a computer program with a set of records, and then writing query structure and query programs, inserting and deleting and things like that. So E.F. Codd created this relational data model to address this problem, and he created a standards and structured way to access the data, which we now know today as SQL. So let's talk about networks. Okay, so before Berners-Lee, there are all sorts of networks around. I mean, it was difficult to communicate with devices outside of one's own network, and even before they had the standard, what they call TCP/IP, there were people actually out there building their own network connectivity to other devices and other computer programs, which didn't even have a standard of that. So Tim Berners-Lee created the World Wide Web. He created the HTTP protocol so you could connect different computers on similar networks and created a standard. So there's another standard coming into play here. So we've got the database standard of EF-COD. We've got Berners-Lee's database, Berners-Lee standard of networks. And now we wanted to connect, with those two standards, we wanted initially to connect databases on networks. And there was errors found early when we tried to do that. So the first solution was, how do we connect all these, banks together, for instance? The idea was to create a hub and spoke model where the banks became these trusted intermediaries in the middle here. You can see that. And the second way is, the solution number two is the blockchain, which is this kind of model, a distributed model, where there's no central authority. And it's actually the very first time in history that's been the case. And the way it's been done is just pretty much by computer science. Somebody came up with this idea of a blockchain, implemented it as a proof of concept using Bitcoin, and here we are today. Everyone's talking about blockchain, and it's a pretty important time for all this to be happening, actually. So, compared with current centralized methods, let's talk about the advantages of blockchain. Well, the first advantage is it creates a trust between unknown parties. And the second one is that distributed records means the data actually can't be lost. So, for instance, if you went into a bank and the bank, had all the computer records destroyed in one place, then you would lose all your money. Everyone would lose all their money, and it would be a tragedy. In fact, that's what happened at one point in the 2008 crash. There was a company in America that had that happen to them. So then also, when you compare with current centralized methods, the transaction costs are reduced and the transaction times are reduced. In some ways, there's an issue with Bitcoin though. It does take a little bit longer to transact these days, and it is taking a lot longer than it used to. But there are other methods of blockchain that are coming on board now, and they will potentially solve those problems. Okay. Well, there's certainly disadvantages to the blockchain, and we know it's a new and it's unknown technology. I mean, there's never been the idea of blockchain, this distributed framework in the history of the world, really. It's always been authoritarian money and distributing things like that. So this is really brand new, and there's no real legal framework for this. It's not really been understood how it can be legally applied, and those things in terms of taxation and that sort of stuff. So it's a new technology, but certainly it's a very promising one. Does anybody have any questions so far? Okay. All right. So we've talked about sort of blockchain being a combination of databases and networks combining and solving problems that existed when we had this hub and spoke model and so on. Let's talk about blockchain and distributed ledgers and what that actually means. Okay, so let's talk about ledgers. I mean, ledgers have always been important. They're the foundations of accounting, and they're as ancient as writing and money, really. every time you've had a transaction between someone in the Stone Age, even. You've got clay tablets, you've got papyrus, you've got tally sticks, you've got your double entry bookkeeping, which started the Industrial Revolution, people would say, and spreadsheets now, electronic spreadsheets, and now on the bottom right-hand corner, you've got this idea of a distributed ledger, which is a copy of this stuff, and it just so the latest incarnation is the distributed ledger, and this is just like an evolution of what it means to be a ledger and to keep track of you know, bartering and communications between people. So blockchains are important because they allow the creation of these distributed ledgers. They build in trust and accountability into the ledger, and because of that, there's no central control authority, and that's the huge difference between these distributed ledgers and what's come before that. Before that, there was always just one authority had accountability, and that one authority had the ledger, and that was basically it. So then, let's talk to the topic about, you know, how can blockchain help the CMDB? Now, when I gave this talk last time, there were people in the audience that said they didn't know what a CMDB was, and I'm just wondering if I could get a show of hands, even in the audience that I can see now, those that do know something about the CMDB. Would you be able to put your hand up if you do? Okay, so that's about half of you. All right. All right. So that's a good thing. So let's go into a definition of what is the CMDB. So the CMDB is basically it's a configuration management database. Okay, so configuration management databases they store information relating to the state of these, well, the configuration items, the parts of the IT estate. They could be servers, they could be relationships between servers, they could be you know, load balancers, devices, network, anything like that. And let me just digress a bit, and I'll show you an example of a CMDB. And this is from this is actually ServiceNow's CMDB. This is my, because I work for ServiceNow, I've been given a personal instance of this product, and you can see here is the CMDB, and this is an example of just part of the CMDB. You can see there's Linux servers, and these are all the Linux servers I've got in my CMDB. So it's basically just like a table. It's a table that stores information about the IT estate. And so for instance, in this ServiceNow example, if I click on this one here, it goes in automatically into the record for that particular CI, this configuration item. Okay, so it is taking a little bit of time, but it will get there, hopefully. So basically all of these, all the records of, so here it is here. So you could see, I don't know whether you can see that on the screen, but this is the actual record for one of the Linux servers that I have in my CMDB database in ServiceNow. And you can see that there's the configuration. It's got the host name, the department, domain, all that sort of stuff. And then down the bottom, it's got related items, runs web servers. You can see it runs Apache, and there's used by these business services, bond trading, client services, and so on. So these are all hyperlinks, and you can click on these hyperlinks. I won't go into the details because that's just ServiceNow stuff. But just suffice to say that this is a working configuration management database, simply just a database of records of devices that we have in the network. Okay, so that's pretty much like a demo example of what is a CMDB. That's the ServiceNow one. And there's various other methods of CMDB. I mean, I've seen companies, their CMDB is just a spreadsheet. I mean, you can have a CMDB just being like a little spreadsheet if you want. If you've got a very small company with 10 computers, you don't need a massive CMDB. You just need a, small spreadsheet really, just to look after those 10 computers, just to see where, what's their end of life, when do they need to be upgraded, when does their licensing finish, and all that sort of stuff. All those kind of configuration things you can keep stored in the CMDB. The difference is when you have a large organisation, say like a bank or insurance company or a very large company that has thousands of computers, you need to have a way of kind of managing that complexity, and that's the real important thing, and that's the whole essence of ITIL, in fact, is to manage complexity. So what we're doing here is we're just managing this complexity using a CMDB, and we have that as a system of record that is common to the whole organisation. Any questions on that? Okay.
Yeah, we're good.
So basically here we have the CMDB. It stores date timestamp changes to the CIs. So if you have a database that's if you have a CI that's being created or it's being commissioned into the network, that's a change of state. That the CI, the server, is being attached to the network, and it comes online, and so you'll want to be able to record when it was connected online and what configuration it has and things like that. And CMDB also is used as a system of record for the ITSM processes like incident, problem, change, and things like that too. So you've got all those pieces of information stored in the CMDB, and they're related. All of those things that happen to CIs, like incidents, problems, things go wrong, new releases, things like that. All of those things that happen to a CI, that's also stored in the CMDB. Okay. So how can the blockchain help the CMDB? Well, it turns out that you can have a secure log created for the devices and events in the data center by using a blockchain. And each one of these nodes, you can see this diagram here, you can see there's a little computer screen which represents a CI or a computer, and there's a ledger existing on each node. So rather than have a CMDB in a central place, you have a copy of the CMDB or a reference to a copy of the CMDB in each node in the network. Now, there was a question, actually, last time I presented this. Somebody said, well, what happens if the database gets too big? I mean, how can you store like a massive database in each node of the network? I mean, it doesn't make any sense. And that's true. There are new technologies now. One is called IPFS. It's called Interplanetary File System. And it's like a BitTorrent kind of thing that sits on top of HTTP networks and things that uses references to the actual database information rather than the actual database itself. So what you have is distributed data using this kind of technology of IPFS to allow that, the fact that you won't have to have so much data stored on each device. So you can still have the benefit of blockchain, but without the weight of the of so much data being contained in those nodes. So basically, the blockchain is contained in private blockchain databases, and there's a daily log of all transactions you can add to the distributed ledger. That could be creating the database, creating a server, changes to the server, like I mentioned before, or you could have individual transactions added to the DL, the distributed ledger. So each time an event occurs, a block is added to the distributed ledger. So what would happen is a block would be added. Say, for instance, if you would commission a server, you would add a block to the blockchain on that server, and then you would spread the information about that event to all the other nodes in the network, rather than keep it in a central place. And that's the benefit of that, is that you have that security built in, but also this redundancy built in as well. Okay, so how can blockchain help the CMDB? Well, the cost, first of all, the cost of maintaining trust and accuracy is reduced dramatically. I spend a lot of time writing, customizing discovery applications at ServiceNow for people to discover their thousands of computers and things like that. We call them discovery applications, and it takes a long time to set these up. Sometimes it can take a few months to set them up, and you pay people to do that. You pay a team of consultants to set up these discovery applications to maintain an accurate CMDB, because you really do need this accuracy thing in the CMDB. Otherwise, nobody's going to use it, right? If the CMDB is not accurate, then nobody's going to look at it for any truth, any information about currency and things like that. So basically, the theory is that if you use blockchain to help the CMDB, there won't be any requirement for discovery projects. I mean, we won't even need to use discovery applications, because each time things change, that transaction record will be captured in a blockchain and then propagated to all the nodes in the data center. So you have that automatic transmission of information and a date time stamped or verified transaction that can't be undone. And as I mentioned, if you go back to what I was showing you before about blocks being added to the chain, each time a block is added, it uses the previous hash to authorize the connection to the next block. So that's the reason why this technology could be quite useful in this environment, because it actually provides proof that this transaction really happened at that date and time, and not just somebody typed it in saying this is what I did or this is what I thought I did and things like that. Okay, that's super important. That's one of the key benefits. And there could be some issues implementing this stuff, and I don't doubt that there are. I mean, I've tried to implement it, and I'm still working on it. I've got a proof of concept stuff happening, and I'll show you a bit later a demo of what I've been up to. But there are some issues, obviously, that technological issues to overcome. But the main benefit of this is good. Yes, question.
You mentioned about discovery and the no need for discovery, but isn't that sort of based on the fact that you put a new CI out there, whether or not it's a server or a network device, it needs to have some sort of blockchain component installed on it?
Well, yeah, you would have that. It wouldn't be a discovery, but it would be a computer program of sorts. Well, let me explain. I'll show you.
I just don't understand what the difference is compared to sort of a traditional discovery component.
Yeah. Well, this is what I would be doing here. I'll just quickly show you. Here's a little test program that I've got here, and basically what you can see is, but basically what these are like little records that I'm using to add into the CMDB, and this is pretty much how things are done, but normally, but they're not done in a way that is set up to be as a blockchain. So this is kind of what happens when you the idea is when you create a server, you set it up in the blockchain like that. So you don't actually have to discover it. It's already there and set up as a date time stamp thing that's set up at that moment. So you don't actually need to discover it. It's actually there. And any transaction that is performed, like this one is a create transaction. There are 4 create transactions here that I'm adding Linux boxes to the database, and that could be an updated transaction. That could be all types of things. You could even have a delete transaction that would mark the record as deleted but not deleted as such, and things like that. So this would doing it this way would remove the requirement to actually do a discovery, because discovery tools, all they do is they scour the network and see what's out there. But if you already have the information in the CMDB based on this methodology, you don't need a discovery tool. That's really the point. That's what I'm trying to explain. I'm not sure whether that's clear enough for you. Does that help? This is super important, because I mean this is one of the key tenets of what I'm trying to explain here, is that this whole idea will save massive amounts of time in deploying and maintaining discovery applications. This is my full-time job in ServiceNow. This is what I do for a living. I set up discovery tools and service mapping tools for customers, and I suppose I'm putting myself out of a job here in some ways, but it does, at the end of the day, it's a much better way of doing it.
Can you go back on that last question for a gentleman who asked here? So a new device will come and it'll have inherent information, including IP address, etc., associated with the machine, right? So when you connect it to a network, it has to connect to whatever is recording or adding to the blockchain. I think the question was about how does that communication occur?
Well, that's a good question. I mean, what happens is my idea is to use IPFS as that network that actually allows that spread of information. So the next stage would be to add, IPFS is like this distributed thing where you can add a file to IPFS, and then it automatically becomes available to all the nodes in the network. And that's the next level above the blockchain. That's the thing that's actually going to allow distributed referencing for the data. So that's actually going to answer it. It's something that I haven't actually added. I haven't included in my particular demo here. But all I've done is create the first level of this blockchain, and it works. It's a demo that works. In fact, what I'll do is I'll just quickly show you the demo. Might as well do that now.
Let me ask a follow-up question to that. Hi, Michael.
Yeah, sure.
Yeah, so that was very clear with respect to new provisioning of new devices, new equipment. What about existing systems? I assume you still do a discovery, and part of the discovery is creating the ledger?
Yeah, I think that's something that I had thought about and certainly discussed it with people, and yeah, you're right. You're going to have some way of putting that data into the blockchain, and there'll be some computer program, and it'll probably end up being a kind of like a discovery tool, if you like, to actually do that. But for new developments and new things that are being added, then you would just be using this idea of blockchain. But certainly, that's a very good question, because that's something that you would say, okay, well, what happens about all the other ones, all the legacy stuff that's out there? What do you do with that? Don't have a definitive answer for that right now, but But anyway, look, let me just show you this demo. This is, basically what I'm doing is I'm going to be adding these new devices these 4 new devices into the blockchain. And so what I'll do is I'll add the Genesis block here, and then I'll add all these blocks here, and I'll try and mine the block at the same time. And that's the thing about mining blocks, and that's a kind of another thing you've probably heard about that people get paid to mine Bitcoin transactions. Well, this is kind of this idea of mining blocks. So it's a pretty simple concept, but it sounds much more difficult unless you can actually see it running. So I'm going to run this project, and what's going to happen is I'm trying to mine block number 1, and it's going pretty quickly. I'm mining block 3. It's sitting on block 3 right now, and there's 4 blocks. So by the 3rd block, it's taking a long time. By the 4th block, it's taking a little bit longer, and so on. And so you can see here, I've got what they call a JSON representation of this. This is my blockchain now. So I've got the very first block is this one. There's Linux 01, and there's the IP address, and there's the timestamp, and there's all the information you need about stuff in the CMDB. So if you saw, remember when I showed you the CMDB of Linux in the ServiceNow view of CMDB, this is just another view. It looks a pretty horrible user interface. I mean, it's just a demo, but it still effectively saves the same information in the same way. You can see hash. So you can see here, the second block there's the previous hash, and you can see that's the hash there. See that where it ends in C1B6. See, there's the C1B6. That's the previous hash, which is an important part of each block. You must have the previous block's information in that block, and then you create a hash of that. So that's the key thing that is important to understand about blockchain. The distributed nature of blockchain is a completely different topic. It's that thing that I was telling you about, the idea of distributing using IPFS. You add what I would be doing in the next stage is I'd be adding each block or combination of the blockchain to IPFS, so that all the nodes can access that blockchain from IPFS. And you might want to host IPFS somewhere you can host it in all the nodes as well. If anybody's ever used BitTorrent, to download movies and stuff, you get all these peers and stuff, and they all help get the information to you, because each one's got a copy of that information. The idea of IPFS, Interplanetary File System, is very similar to that. Okay, so here's just an example here of the blockchain that I've created, and that's the actual blockchain. And then the very last thing I do is I validate the blockchain. I check to see, is this blockchain valid? And that's what people do all the time. This function is chain valid, and you check to see whether the chain's valid at any possible time you want. And that's and basically you're just checking to see that the previous block has the same is the previous hash of the previous block is contained and is the correct one. That's really what you're doing. You're just checking back through the chain. So you can do that if with Bitcoin. Bitcoin's an open source kind of thing as well. You can see, you can validate those blocks and so on.
Michael, one more question, if you don't mind.
Yeah, absolutely, please. Well,
I'm not clear about how blockchain is processed. Does this mean that the larger the estate, the more calculating each node needs to do?
Yeah. As you can see, the mining took longer, and you have this thing called a level of difficulty, and that's interesting too, because okay. Let me go back to this demo here. The level of you can see each time you try and mine the block, there's a level of difficulty, and right now I set the level of difficulty to 5, which is really low. At the moment, I think that Litecoin has a difficulty of like 400,000. And each time a block is added, the difficulty gets more and more, and it takes longer and longer to mine it. There are other solutions though. In order to mitigate that problem, there are things like IOTA. IOTA is a framework, a blockchain framework that's being brought online now, and that's used to mitigate this issue. Like the more nodes you have, the easier it becomes. That type of thing. I strongly recommend everyone, if you're interested in this new blockchain stuff, IOTA is a really good way to go. I'm looking at that myself. But this idea of difficulty, and it gets more difficult the more there are, because you could actually see the demo. It didn't take much time. It took hardly any time at all to mine that first block, and then when you mine the second block, it took a little bit longer. And by the time the fourth block, so if you increase the difficulty to say 6, I'm going to do that right now. So I'll save that and run the computer program again to mine these 4 nodes. See, I'm just basically creating these nodes and adding them to the blockchain, right? So I'll just do that right now. Increase the difficulty from 5 to 6, right? Just one more. And let's run it and see what happens. So all of a sudden, we find the difficulty is only increased by 1, yet I mean, running it on a MacBook, and it's fairly fast, but it's taking its time. It's probably going to take quite a long time to mine it. There's nothing wrong with the computer. It's running perfectly. I'm able to speak to you on it and so on. But it's mining the block, and it's taking its time because the difficulty is harder.
Understood. Thank you.
All right. So anyway, get back to that. I won't, because it may, but if there's any time left, I'm not sure how much time we've got left, Marilyn. A few minutes.
Yeah, keep going, Michael. Everyone's okay here.
All right. So that's kind of the idea, and I think it's useful to see that demo because it kind of puts things in perspective. It's not like this blockchain. It's just a computer program with data, and that's all it is. And it's fairly easy to create these computer programs to run and just test out to see how this stuff actually works. Okay. So basically, there's another thing also I was talking about, because I do this sort of on a daily basis, and this section here, this one here is
just a question, Michael.
And verification.
Yes,
of course.
On your question box, there's a question there that says, what do you mean mine a block?
Mine a block is basically actually converting the data and cryptographically signing it so it can be added to the blockchain. So you add a block, and then you create the block itself, and then you add it by mining it. That's kind of mining it and adding the block to the blockchain. And when you mine blocks in, say, Bitcoin, you've got all these miners, actually, that they call them miners, and they have all these like racks of computers that are used to get that cryptographic signature that is the actual correct one that allows that block to be added into the blockchain. That's what mining is. It's just an expression, and it doesn't mean actual mining, but it's like it's the idea of mining the cryptographic key, if you like. There's a proof of work. There's an actual effort involved, a computer effort involved in that, and that's what the mining is, and that's why it takes time. It takes computer processing power and processing time to create those cryptographic signatures. I hope that helps to answer that question. Anyway, so getting back to this, I was just going to say that if you use blockchain and you use the distributed method of blockchain becomes a distributed system, you won't need to provision credentials or verification of credentials, because there won't need to be any credentials. It'll all just be set up that way. IPFS will sit on top perhaps and provide that cryptographic interface to the information. You won't need to run these discovery tools anymore. Everything will just be like sitting there. It will be static. It won't be. You won't need to verify each time things change. Oh, what does the network look like today? Is it different to what it was yesterday? Because each time a task occurs, that task or that event will be actually captured in the blockchain. and it'll be, you cannot undo it once it's there. So let's go quickly to the use case. The first one is ITSM processes, and the first use case would be the event would be create. What we would do is we create an incident, problem, or change event. In a normal CMDB, you just associate CI with the event and add the event to the CMDB table. In the blockchain, you would add a block to the distributed ledger, as I just showed you. Just add a block. I added the create block. You could add a update block or any type of block. It's like a type of addition to the blockchain, and then you copy that distributed ledger to all the nodes using IPFS or some other method. Similarly, when you update an incident problem change, you update the CMDB table. Same type of thing on the blockchain. When you close an incident, you update the CMDB table in a normal CMDB environment. And with a blockchain CMDB, you would be adding a block to the distributed ledger and copying that again. That's kind of the idea. That's the theory behind it. So let's have a look at use case number 2, which is automated discovery of data center devices. Okay. So this, what you do is all changes to devices, the CI, these configuration items, so devices, they're registered on the distributed ledger of the device. So if you have a change to a device, you set it up so that your configuration management system, that distributed CMS that's captured, it's a computer program just like the one you saw in my example. It will be running, and it will create that change to the blockchain, and then it will spew it out to the rest of the network, right? So copies of the DL will be sent out to all the other network nodes, and this is all authorized using cryptography, so it's quite secure. It's got hashes that are constructed of the data in the node itself. So that's the key thing with this. So let's have a look at comparison of discovery system versus blockchain, and that was it. That was kind of the question that gentleman had before. When you commission a device in a network, that's the easy bit, because with discovery assisted CMDB, you commission a device in a network, and then you set the discovery tool to scan and find the device, and it adds the CI record of that device into the CMDB. So and in the blockchain scenario, as a device is connected to the network, and you can see that if you remember back to that idea of the record, it's got IP address in it, so you can actually add it to and then use that as a connection point to all the other nodes in the network. So a new transaction block is added to the CMDB blockchain and then distributed out to all the other nodes in the network. When you update a device, say in the discovery assisted CMDB, this is the current method of CMDB discovery. Discovery will scan and find the device and update the CMDB with the updated information. With the blockchain CMDB, you would add an updated transaction block to the CMDB blockchain, so and then propagate it as before. And when you delete a device, same thing. Discovery fails to find a device, and it will at some time either remove it from the CMDB or what they call is mark the record as deleted, so that it won't appear in the main section of the CMDB. And in the blockchain CMDB, the idea is to add a deleted transaction block to the CMDB blockchain. So you're adding another event to the blockchain about that particular CI. That makes sense. So in conclusion, accurate, reliable, secure CMDB is achieved without using a discovery tool, and devices secured by the existence of a local copy of the CMDB on each node. So the cost and therefore the cost of the CMDB maintenance is reduced dramatically, because you don't have to pay license fees for discovery tools or things to keep the CMDB accurate and reliable. It's already reliable. Each time there's a transaction, it's captured in the blockchain, and it's kept there forever. And it can't be disputed. There's no disputing of this. And also the distributed technology means that there's no single point of failure either. So that's also a benefit. So that brings me to the end of my talk, and if there are references as well, I think that these slides will be distributed if people want a copy of them. There'll be a link. I think Marilyn or somebody will allow people to get a link to this presentation. So here's some references as well that I used to create this presentation that will be in as part of the slide pack. And so if there are any further questions, I'd be happy to open it up to questions now.
You've got a question?
Hello, Michael. Full disclosure, I actually do the same kind of job for you, just for a different consultancy on ServiceNow. So I'm aware of discovery, service mapping, all these other tools that you've got.
Okay, cool.
Looks like a decent technology, but what we've not discussed is devices that don't use a full OS that would still be in the CMDB. So things like your switch stack, for example, or your switch ports for your network devices with that routers. So this type of information that you wouldn't normally have like a blockchain program to work on. I can understand Linux boxes, Windows boxes, laptops, that sort of thing. Yeah, no problem. Sounds like a good idea. You could have a decentralized CMDB, but I don't understand how you would capture devices that don't use a full OS that would still be included in the CMDB.
Yeah, that's a very good question. I don't know the answer to that, but I could say that perhaps that you could modify the configuration management system to interface with those other devices that currently don't have an interface. I mean, I know when we were trying to, the example would be, with the network devices, you connect to them with Discovery on port 161, and then you can get information using the community string, and you can get all that information straight away from there. There may be a way that you can, create a computer program that will extract that information and add it to the blockchain. It's just a matter of programming, I think, and that's the essence, I think, of this whole idea of blockchain. It's all about computer programming, and I think in that regard anything's possible. I think right now, you've got the Linux tools, and you've got those tools that you can create. You've got Java. I mean, my example was in Java, and I think you could perhaps even write a Java program to sit on like an agent or something, perhaps on these devices. That would be my suggestion. Does that kind of make sense?
Yeah, kind of.
Yeah, kind of. Okay.
Michael, there's a few questions on the question panel. If you have a look at that there, I think the first one there is every.
I don't know where's that question panel. Sorry.
We've got question panel on the right-hand side under your the panel.
Okay.
First question is, does every peer need to have a full copy of the distributed database?
Every peer would have a pointer to a copy of the database. It's like a reference to it. I wouldn't suggest having a full copy of it, because it would be very cumbersome, and you could have that located somewhere else in other parts of the network, perhaps. I would say that the actual implementation of this distributed part of the CMDB blockchain would be utilized by this technology called IPFS, which allows the ability to add nodes into the IPFS network, and you can actually see them from every other node. And you can have copies wherever you want. I don't think you would have to have copies in every node, although I have said said that at some point, but it's flexible, I would think. The answer to that question, the definitive answer, probably in the next month or two, if I get some time, I'll be able to create that next level and of a demo, and perhaps even create the very first blockchain CMDB to show people. But I think, yeah, that would be the answer to the question.
Okay, another one there is what software would create the CMDB record? Is it a blockchain app initiated on each PC server?
Yeah, it would be a distributed CMS, a configuration management system. That's what I envisage. That computer program that you saw running would be running on all the different nodes, like an agent. Monitoring tools have agents running on each node. Perhaps this would be the same kind of idea, running an agent on each node to do that. Yep.
Okay, great. Next one is what barrier does the proof of work time delay present to the frequency being able to update the CMDB?
Well, that's a good question. If you put the level of difficulty, say, down to 0, like at the moment it was 5 or 6. You can see that if you put it to 0, it doesn't take much time at all. So in an internal network, where there aren't any, we're not talking about mining, and we're not talking about money or cryptocurrencies or things like that, things that are, have to be dealt with that way. You could reduce that level of difficulty down to 0 and have the mining take very much shorter time.
Great, thank you. And the next one is what piece of equipment will mine the new blocks when the new item is added or updated or deleted?
Well, it's the actual item itself. The node itself will have a running computer program that will be able to mine its own block and create an additional block into the blockchain, and then that'll be sent out to all the nodes to verify the efficacy of this, or the validity of this transaction.
Okay, and another one here is intrigued by your sorry, I don't have my glasses, but I'm trying to read it. Intrigued by your idea of use of blockchain for maintaining CMDB. What are your thoughts on about blockchain for managing DNS, or even, and I can't read the rest of it from my panel here, I'm afraid. So
yeah, that's a very good question. DNS is a different way of managing. I mean, DNS started off, it's like the very first IP addresses, and then they had to have names for those computers. And there's kind of like this whole idea, this new idea of, I'll go again, I'll talk about IPFS. This interplanetary file system will allow us, instead of location addressing a file by its location, like, HTTP amazon.com/record or whatever, you'll actually be able to say, I want to look at that particular record, and you call it by name. So the whole idea is I think this new view of the internet is going to change everything in regard to this. Even DNS will become kind of a redundant kind of technology, where you'll have, instead of location addressing, you'll have this new idea of content addressing as opposed to location. And I strongly recommend everyone that on the call perhaps to look at the this new technology called IPFS. It's pretty important stuff. I think that blockchain and IPFS together, I think there's going to be some really interesting stuff happening in the near future, actually. And that one of those things will be the DNS solution and so on.
Is there any more questions from the room here? No, okay. I know we've took a lot of extra time this evening, Michael, with all those questions that have happened throughout, so we have overrun a bit here. But I hope that people have found that useful this evening. And I'd just like to thank Michael for giving up his time and getting up early to present to us. So thanks very much, Michael. And
thank you. Thank you very much.
It's like 4 in the morning now, probably 5 in the morning. I think it was up at 3.
Yeah, 5 a.m. now, so ready to get up and go to work.
And thank you to all the people who have also dialed in to this event this evening. I hope you've also found it useful. Please look up the BCS events if you're actually in London and able to come to any of our events in future, or certainly to our conference next month. So if there's no further questions, then we'll just thank Michael. So, and people, please feel free to go and have some refreshments outside. They're in the BCS office. Great, thank you. He just hangs up straight away.
I'm still here.
Oh, did you? Just your video just clicked off, and I thought, oh, you just jumped.
Yeah, I know. I just stopped the video, but I can still see you guys. So, okay, take care. Have a good evening.
Sorry. I don't know. I think we've got all those questions. I'm not sure if there's any more questions there that we didn't answer. Michael, if you want to have a quick scroll.
Can you show me where that is? Because I'm not quite sure.
The GoToWebinar panel on the right-hand side.
Yeah.
So down the bottom of the panel, I've got a box that says question. There's a drop-down arrow. It's actually the second last from the bottom. If you start from the bottom of the grey windows, it says panels. It says chat, then handouts, I think, and then above it is questions.
I got audio. I don't see anything with questions. I've got polls, chat.
It's directly under
web. I don't have that, Marilyn.
Oh, okay. Well, I think I've got them all. I'll actually get Simon
I can't see it.
Capture them.
Okay.
Hi. Yeah. Sure. Hi, Vincent. Nice to meet you. Vice Chair for this group, yeah. Okay.
Okay.
Hang on, let me just go outside the camera so we can see you.
Okay, see you later. Bye.
Because I think we'd love to have you come to our conference and be a presenter. I've still got some slots left for speakers if you're interested.
Yeah, I can send the slides to you first. Yeah. And these slides actually not just created by me. I've got 3 professional coders. Yeah. So I pretty much share the contents of this identity. Yeah. So the thing is that I start from more conceptual stuff and then bring from the fundamentals of blockchain, which I start from generic 4 components similar to the white box. Okay. So it's sort of flow that leads people to better understanding. And then basically then you talk about the third side, yeah. Talk about the cryptography and the I'm trying to do it in such a way that people who come have that solid understanding so that they go out much more better.
That would be awesome. Yeah, it's certainly collect new information. We would love to, I'm happy to get you into that conference. But also, and what you can do is you have to get where you have a little bit more time to go to conference slot actually 40 minutes.
40 minutes is fine.
Yeah.
I'm trying.
Let me get your details as well, because then I can at least email you and get you ready.
You have thinking?
I do.
Okay.
Is that easier?
Is that much quicker?
Okay.
And then I'll get your
sure.
email address straight away. This room is covered.
Yeah.
Is the conference next one?
Yeah, it's May the 23rd, so it's about 6 weeks away. So I'll send you an email and I'll work with you something to get a hotel, a little abstract similar to what I can come up with about what the topic is about, the special topics, so I can advertise your event as well. And obviously I'll send you all the details for access and getting an invitation, etc.
I also have a small group of friends who are two friends who are actually doing the mine itself.
Yeah.
So it's like I can actually show buy
Yeah.
If only there's additional time, not that it's fun.
Yeah.
So if not, this is just.
So that's not a product to sell, is it?
No, it's not.
Yeah.
It's just to give people an idea how to really do mining at home.
Yeah.
And you actually do it by yourself.
That'd be great. I would love to see
but
that.
we might actually do a short video and then put that and then just showcase it.
Yeah.
Instead of just explain on the
That'd be
spot. Otherwise, you know, just time.
great. So just put your stuff in there.
Thank you so much.
No,
and your email?
So yeah, it's Marilyn. Just check what it is in BCS mail address.
You have a card.
I need to cards actually. I've been saying it quite a lot lately.
I can write it straight away.
It's Marilyn. M-A-R. I-L-Y-N. That's I-L before the Y.
L.
Yeah. It's cool. Dot grading at BCS CMSG .org.uk.
Thank you very much.
Okay, yeah, perfect. No, thank you. I'm very impressed that you were able to join us.
Yes. So yeah, I actually come to this event just to see whether there's a chance. I realized there's a lot of options in our event.
Yeah.
And you can find like
Yeah.
design these materials. So
Yeah.
when it comes to the explanation of the issues in which just totally skip it.
Yeah.
And then all those skills totally like.
I know it's very hard. It's a lot of information for people to learn.
But if you do it correctly,
Yeah.
then you actually can bring people to the dots. I mean,
Yeah.
connecting the dots. All they want is that idea. So I have tried that. So I hope my presentation is
Yeah.
I have to practice.
So the only thing I will say is we could, if you could, like at the end of it, or somewhere through, talk about how it would be, like
In this case,
with something with respect to how it's used.
Okay.
Yeah, so his slides are probably useful around how, updating the CMDB. It's really about how, I think the questions that came up tonight maybe were people like, sure, we know how the CMDB works when we have our automated discovery, but how is this thing doing it in the background? Like, how is it a benefit to us? And that's really what probably would be the question to answer.
actually, this answer is quite straightforward. It's
Cool.
decentralized information.
Yeah.
That means it's done automatically
Yeah.
without the involvement of the human being
Yeah.
to actually involve
To validate or make errors, etc. Yeah.
So it's the
Yeah,
automation
great.
part.
That's all we need then. That's great.
Thank you so much, Mary.
Oh,
Yeah,
very
cheers.
nice to meet you. Thanks for coming.
I will send you a slide, so feel free to let me know as a talk. Maybe we can cut out some material. It's too much.
Yeah.
I'll try to accommodate within 8 minutes. That's what you're
Yeah, yeah.
And it's a holiday event?
It's holiday, so it's 40 minutes You get 5 minutes of questions. So if you actually went to 45, you didn't have questions for that candidate somehow, then that would fall as well, but we did cut you off at 45 because we're still kind of thing.
I can find time to.
And we just use a 3 room, so we have all 3 rooms open in the morning for keynote speaker.
How many people?
Which is about 120. We'll find the idea of the room. So the keynote speaker will get the national free, but we would have to have everybody. But it really depends on who's all running alongside as well, so you might get everyone. Yeah.
But it's a good try.
I'll definitely send you all the details and we can call and talk about that later.
When exactly?
It's the Wednesday the 23rd.
Okay, that's good.
So yeah, and it's at 9 o'clock in the morning. It goes to 9 o'clock in the evening, but it actually finishes at 5:30. We haven't opened the meeting for this professional activity, we will be doing and why. There's all your fees provided for everybody as well.
The reason I say it's great because I will teach my time to it's on Tuesday or Thursday, then I probably.
Yeah.
Wednesday.
Fantastic.
Thank you so much. Thank you.
You're welcome.
See you later. I'll send you those details, then we can correspond. Thank you.
Thank you. And it was really difficult because the panel was diving for me to try and read them off. So
Right.
he couldn't even find a question.